Hello friends, welcome to Sidza.com. Now in this video we'll learn about the peroxide effect or the Kharash effect. What it is? It's actually the anti-Markovnikov addition. In our last video we learned that when there is addition of an asymmetrical reagent to an asymmetrical alkene, the hydrogen goes to that double bond in carbon with more number of hydrogen atoms. But over here the addition will be anti-Markovnikov addition, means hydrogen will not go to the double bond in carbon that has more number of hydrogen atoms, rather it will go to the double bond in carbon that has less number of hydrogen atoms. So we got here a carbon-carbon double bond. So in an anti-Markov addition reaction, which is also called the peroxide effect or a Kharash effect, the hydrogen will go to this particular carbon, right? It will add across this particular carbon, the carbon that has less number of hydrogen atoms, right? The double bonded carbon that has less number of hydrogen atoms, right? So then what will be the product? The product will be, you got the CH2 now, single bond CH2, single bond CH2, and the CH3. We had a double bond over here. The hydrogen will go to this carbon, right? And then the Br will be over here. So this is what? This is a anti-Markovnikov addition, and this anti-Markovnikov addition of HBr occurs only in presence of peroxide, right? So suppose we take hydrogen peroxide. In presence of hydrogen peroxide, HBr adds across the double bond and it follows the anti-Markovnikov's addition. It doesn't go to the double bonded carbon that has more number of hydrogen atoms, rather it goes to the one which has less number of hydrogen atoms, right? So that's why it's called anti-Markovnikov addition, and this is the anti-Markovnikov product, right? Now let's see why. What is the reason for this, exceptional behavior? Because in presence of peroxides, the addition of HBr to the alkene is not an electrophilic addition reaction, rather it's a free radical addition reaction. What it is? It is a free radical addition reaction. In our free radical addition reaction, in our last video we learned that when HBr in absence of a peroxide adds across a double bond, addition is electrophilic addition reaction, right? But now the mechanism is different. It's not electrophilic addition, rather it is free radical addition reaction. Let's see how. In presence of peroxides, we know, suppose we got the hydrogen peroxide and the peroxide linkage is OO single bond. In the hydrogen peroxide, actually over here what happens, the homolytic bond fission occurs first, and what do you get? You get HO free radicals, right? 2 molecules of HO free radicals, and this is the step number 1. And in presence of peroxides, the HBr, again there is not a heterolytic bond fission, rather there is a homolytic bond fission, right? So this HBr reacts with the HO, and in the HBr again there is now homolytic bond fission rather than heterolytic. In our last video we learned there is heterolytic bond fission. Both electrons, they go with the bromines. It forms H plus and the Br negative in electrophilic addition reaction. But right now, what is the bond fission? Homolytic. Hydrogen takes 1 electron, bromine takes 1 electron, and that hydrogen reacts with the OH and it forms the H2O plus the Br free radical, right? It is this it is this free radical here, the Br free radical, which attacks first in case of a carbon-carbon double bond, right? So if you have a CH3 single bond CH2 single bond CH double bond CH2, now the Br free radical will attack on it, and again it will form a free radical which is more stable, right? So therefore it will attack on this one because the free radical will be then over here, right? So you get a CH3 CH2 single bond CH, now CH2, and the Br is over here, right? Okay, so this Br will be here and you get a free radical here, right? If suppose this particular, if for example this Br attacks on this one, then the free radical will be over here, right? But that's unstable. That's a 1 degree free radical, right? So that addition will not occur. Always the reaction follows the most stable intermediate, right? So that's why the free radical will be over here, which is the secondary one. That's why the Br attacks on this one, not on this particular carbon, right? And then in the second step, the H free radical will attack on this one, on this particular carbon. So you get CH3, CH2, single bond CH2, CH2 Br, right? So over here, this is anti-Markovnikov's addition reaction. Let's take now another example. Suppose we got a CH3 single bond CH double bond CH2. Again, when you react to the HBr in presence of peroxides, hydrogen peroxide, let's take an example, and what happens? Anti-Markovnikov addition will occur. Hydrogen will go to that double bond carbon that has less number of hydrogen atoms. So that means hydrogen will go over here and the bromine will add across this carbon. So what do you get? You get the CH3 single bond CH2 now. Now single bond CH2Br. The reason? Again the same, right? Homolytic bond fission, right? The reason? The same. The homolytic bond fission will occur first in peroxides. So peroxides break down, and in presence of peroxides there's a homolytic bond fission again in HBr again, right? HBr, so there's a homolytic bond fission, right? And you get H2O plus Br free radical, and it is this free radical, Br free radical, that will attack first on the terminal carbon, right? So it will attack on the carbon CH3 CH double bond CH2. So attack of the Br free radical will be on this one, and what you get? You get an intermediate like this, CH3 single bond CH single bond CH2Br. Okay, CH2Br, and the free radical is over here, right? And then in the second step, in the last step, the same free radical will be under the attack of H free radical, right? And it will form what? CH3 CH2 CH2Br, right? CH2. What if the same Br free radical attacks on this one, right? In that case, you get intermediate like this, CH3 CH Br here now, the central carbon, and you get the CH2 free radical. But this free radical is what? This is a 1 degree free radical, right? This is a 1 degree free radical, and this one is a secondary free radical, and we know order of stability of the free radicals is secondary is more stable than primary. Okay, so that's why the major product is a secondary free radical, and that's why the Br will attack on the terminal hydrogen, terminal carbon, and over here this will be a minor product. So then from this one, when H free radical attacks on it, right? So what you get? You get the CH3 CHBr and the CH3, but this is a minor product, right? And this one will be a major product, and this is called as a anti-Markovnikov product, and this is the Markovnikov product. So that means addition of HBr, right, to unsymmetrical alkanes in presence of peroxides only, right, takes place contrary to the Markovnikov's addition. That means hydrogen adds to that double bonding carbon that has less number of hydrogen atoms, right? And remember, this Markovnikov addition or peroxide effect, crush effect, it's the same, and it is observed only with the HBr in peroxides, right? Now let's take an exercise. Let's take now let's take some questions here. When I add here in this molecule, when we add here the HCl, so what will be the product? It will follow the Markovnikov's rule, hydrogen will go over here, the chlorine will go here. So the product will be like this, right? So you get the CH2. Now the CH2 will change into CH3 and the chlorine will be over here, right? If we add the HBr, again the Markovnikov's rule, right? The addition follows the Markovnikov's rule and you get the product like this. It is now CH3 and the Br will be over here. But if we add HBr in presence of peroxides, hydrogen peroxide or the benzoyl peroxide, the addition will be now anti-Markovnikov's addition, right? So hydrogen now in this case will attack on this particular carbon and the bromine will go to the CH2. So here over here the product will be like this. It is the CH2 and the bromine will be here and the hydrogen will be here. This is the anti-Markovnikov's addition. This is anti-Markovnikov addition and this one is Markovnikov's addition. This one again the Markovnikov's addition. Right? Hope you got the concept. Thanks for watching the video. Bye for now.